Okay, this is 7.4 trig ratios practice problems. So let's get started here with number one. We need to find the value of each trig ratio. So it looks like for number one, we're looking at angle A here. So we should definitely label our sides. We've got the side across from the right angle, that is our hypotenuse. The side length next to the angle, but not the hypotenuse, is the adjacent side, and the side way across from the angle is opposite. All right, once you have those labeled, we can just use SOHCAHTOA to remember what order we have to have these in, what's on the numerator, what's on the denominator. So for cosine, we have adjacent over a hypotenuse. So that is going to be 40 over 50. Remember to reduce these. We just divide them by 10, be 4/5. The tangent of A, tangent is opposite over adjacent. So that is going to be 30 over 40, which reduces down to, 3/4. And the sine is opposite over hypotenuse. So that one is going to be 30 over 50, which reduces down to 3/5. Okay, so I think you guys know how to do that. Just make sure you label them. Super easy. All right, now 5 through 13, we are finding the missing side lengths and rounding to the nearest tenth. Okay, so we are looking at this angle here, the 71-degree angle. So let's, always want to label our sides first. Okay, so we have the hypotenuse and the opposite. The side length would be adjacent, but we don't really need that for this problem. So what we know is 11 with the hypotenuse, and what we need to know is the opposite. So we're going to be using O and H. Which trig ratio uses O and H? That's going to be sine, right? So we do the sine of 71 is equal to x over 11. And if the number is in the denominator, right on the bottom, we can just multiply it out. This will cancel out, and you'll just be left with x on that side. You do it to one side, got to do it to the other. So now pull up my calculator and do 11 times the sine of 71. Let's see, there we go. 11 times the sine of 71. Press enter. Looks like 10.4 is our answer. 10.4. There you go. 6 is going to be pretty similar. 7, we'll do number 7. Again, always start with labeling our sides in terms of the angle that we're comparing. So we're looking at this 50-degree angle. We've got on the side that's 15. That is going to be our adjacent side. And across from the right angle is our hypotenuse. And we don't need it for this problem, but we can label this as our opposite side. And so what we know is 15 is our adjacent side, and what we need to know is the x, the value of x, which is our hypotenuse. So we're using a over h, which uses that. That would be cosine. Okay, so we're doing the cosine of 50 is equal to 15 over x. All right, and now for this problem, we have the variable is in the denominator. So what we do is we just switch these out. So this x is equal to 15 divided by the cosine of 50. And now we can go to our calculator, clear this out. 15 divided by cosine of 50. And we're left with 23.3. We could also do this as a fraction. 15 over the cosine of 50. And you see we get the same answer, 23.3. 23.3. That's pretty much the two types of problems you're going to see on here. So I'm going to let you guys do the rest of these problems here. Either you're going to have the number in the denominator, right in the bottom of the fraction, like we had with number 5, and you can just multiply on both sides to solve. Or you have the variable, the x in the denominator, and what you do is you switch it out like we did with number 7, and then we just divide. Okay, so that's the two types of problems. So you guys should be able to do the other problems there. Let's look at the back side of your practice problems. 14 through 16, we've got some word problems, so we need to definitely draw a picture for these. It'll help us out. So I'm going to do a couple for you, and you guys can finish them out. So number 14 says a flagpole casts a shadow that is 137 feet long. Okay, so let's start with that. We got a flagpole. We're talking about a shadow, so that's casting something that is the shadow's on the ground, right? So this is 137 feet long. The angle of elevation between the end of the shadow and the top of the flagpole is 25 degrees. Okay, so it looks like the angle of elevation here is right here, and we need to figure out how tall this flagpole is. So we need to figure out x. Okay, so there we go. That's set up. I guess we'll do this one fully. So this is the angle that I'm comparing. The right angle is going to be created with the ground and the flagpole. So this will be the hypotenuse. 137 will be our adjacent side, and what we need to solve for is our opposite side. So it looks like we're going to use tangent because we have opposite over adjacent. So this is going to be the tangent of 25 is equal to x over 137. And we have the number in the denominator. So we're going to just multiply by 137 on both sides. And we should be good. We should get x is equal to 63.9 feet. Okay, number 15, an archer shoots an arrow with an angle of elevation of 42 degrees at the target that is 50 feet off the ground. How far did the arrow travel in the air? Okay, so let's start with the target. Here's a little target here. This is 50 feet off of the ground. And we've got an archer here. He's shooting a bow and arrow up at a target with an angle of elevation of 42 feet. And okay, so what do we need to figure out? We need to figure out how far the arrow traveled. So the arrow would not be this length. The arrow would be our hypotenuse. So it looks like that's going to be the side we need to figure out. So I'm going to let you guys handle this one, try to solve for x. And number 16, an escalator has a vertical rise of 196 feet and rises at an angle of 10.4. How long is the escalator? Okay, so vertical rise, vertical is like up and down. So vertical rise is 196 and angle rises at an angle of 10.4. All right, so there we go. How long is the escalator? So do we need to figure out this or this length? I'll let you guys figure this out, see what you come up with. All right, make sure you label all the sides in terms of this angle. All right, let's look at the application section now. 1 and 2 are just a little bit kind of a warm up for these, so I'm not going to help you with those. But let's look at number 3 together. Okay, so the algebras go paintballing. Mr. Kelly and Mr. Sullivan climb up and lie on the top of a shed that is 5 feet off the ground. Okay, I'm just going to kind of draw this out as I go. All right, so here's the shed. And Mr. Kelly and Mr. Sullivan are on top of it, okay? So here's old Kelly and Sullivan are over here. The others send Mr. Brust into a tree to hide. He was doing a great job picking up the competition when he stands up and shouts, "Gee, guys, gee, I'm in a tree." The guys on the shed decide just to take him out so he doesn't give away their position. They look up at an angle of elevation of 65 degrees, and they know that the tree he's in is 40 feet in front of them. Okay, so how far will Mr. Brust fall out of the tree when they shoot him? Okay, so let's see here. So it looks like in front of them, we know that there is 40 feet, and then there's this big tree. So here's my tree. pretty good artist. There we go. Here's my tree. All right, and Mr. Brust is in there. So there's a B for Mr. Brust. Now, Kelly and Sullivan are looking up at an angle of elevation of 65 degrees. And so we need to figure out how far he's going to fall. So we need to find this value here. Okay, but let's also remember that this shed is 5 feet tall, which means he wouldn't just fall this distance, he would also fall an extra 5 feet. So let's remember at the end to add 5. Okay, so let's go ahead and label our side. So we have the side length, that would be 40 feet. That would be our adjacent side. And the length that we need to figure out how far he's going to fall is going to be the opposite. So looks like we'll be using TOA, right? OA. So we're using the tangent of 65 is equal to x over 40. And the number is in the denominator. So all we have to do here is multiply by 40 on both sides. All right, let's pull up our calculator for this one. All right, 40 times tangent 65, we get 85.7. Let's go ahead and just round this to nearest whole number. Let's call this 86 feet. And so 86 feet, x would equal 86 feet. That's how far he would fall from the tree to the roof of the shed, but we also have to add on that 5. So he will fall a total of 91 feet. Yikes. All right. Number 4. All right. Mr. Kelly wants to hang icicle Christmas lights and wants them to cover exactly from his roof to the top of the window. He doesn't really want to get up on the ladder to measure, so he decides to use some trigonometry. Sure. He walks 25 feet away from his house and measures the angle to the top of the window to be 59 degrees. Then he measures the angle to the roof to be 66. How far will the icicles hang? Okay, this one's a little bit rough. Okay, let's start with a house. Here's a house. Okay, and Mr. Kelly, we'll say, is 25 feet away. Okay, this is 25 feet. Here's old Kelly. All right, so it looks like, I'm going to say this is like the window is maybe here. Okay, so it looks like we've got 2 different angles of elevation going on here. So we have 59, which would be here, and then we have the bigger angle of elevation to be 66 degrees. Okay, so now we're going to have to do 2 different problems here. We're going to need to figure out x from here to here. We're going to have to figure out this length in terms of this smaller triangle, and then we're going to need to figure out this x, okay, from the top of the roof down to the floor. So, and then once we have both of those, we can just do some subtraction and figure out how far that distance would be. So I'm going to leave the rest up to you. You guys go ahead and solve this one. I'm excited to see how you guys do and what you come up with on this one. All right, good luck.